Okay, so we have a series parallel problem. Our very first step is to solve for the resistance on the parallel circuit. So this portion of the circuit, I need to figure out my resistance for that circuit. And to do that, I use my 1/1 method. And so I put 1 over the top and then 1 over each individual load or resistor. Not this resistor, this is the series portion, but the parallel. So I take each resistor and I will add those two together. First, I need to find a common denominator. So my common denominator is going to be 12. So this would be 4 12s plus 3 12s, which is equates to 7 12s. Okay? And I take that one step further, and that's going to be 0.5833. Go out to the fourth spot past your decimal. Now I still need to divide 1 by 0.5833, which equals 1.713. So this figure here is my resistance total for my parallel circuit. To find my resistance total for the entire circuit, I need to add this to my resistor, my 2 ohm resistor that's on the series portion. So just to further explain, I'm going to simplify this circuit. Here's my battery, here's my resistor, and then this resistor represents these two circuits in the parallel branch, and so that's going to be 1.713. And as a series circuit, we know that we can add the two resistors to come up with our total circuit resistance. So for our total circuit resistance, it's going to be 3.713. Okay, I'm going to go ahead and erase this. I'm going to go ahead and erase my 1/1 method, because now I have solved for resistance total for the entire circuit. I've got my voltage total is 12 volts. Now to figure out my amperage, again I use my formula V over I times R. So if I factor in my voltage divided by my resistance total, I come up with an amperage total of 3.2307. That'll be my amperage total. So I know that throughout this entire circuit, 3.2307 amps will flow through. In a series circuit, we know that current remains the same throughout a series circuit. But in a parallel circuit, the current splits off, depending upon the load or the type of resistance in that circuit. So to begin with, I know that I'm going to have 3.2307 amps flowing through this resistor. Now, the next step that I need to figure out before I can split up my current is to figure out my voltage drop on this resistor. And I do that by taking my current times my resistor. So 3.2307 times 2 equals 6.4614 VD. That's my voltage drop. I know that I have a total of 12 volts. So that will help me determine how many volts I have left for this branch. So I have determined that I've got 5.5386 volts available for this branch and 5.5386 volts available for this branch. My next step is to determine how much current I have available for this load. Same thing for this one. So I take 5.5386 divided by 3 equals 1.8462 amps flowing through this load on this parallel portion of the circuit. I do the same thing for this lower load. 5.5386 divided by 4 equals 1.3846 amps. So I know that I can add these two figures, and by doing that I should come up to a sum of about 3.2307 amps. That'll confirm that current remains the same throughout the circuit, but in a parallel portion it splits off. My voltage drop at this portion of the circuit can be determined by multiplying 3 ohms times my 1.8462 amps and I should come up with my 5.5386, and that's perfect. 5.5386 VD. I'm going to do the same thing for here. 4 ohms times 1.3846 amps, I'll come up with 5.5386. So my voltage total is 12, my resistance total is 3.7143, and my amperage total is 3.2307.